Now we're going to look at infinite limits. In the intuitive definition of an infinite limit is as follows. Let f be a function defined on the sides of A except possibly at A. So they probably mean defined near A except possibly at A itself. Then limit x approaching A of fx is infinity means that values of fx can be made arbitrarily large as we please by taking x sufficiently close to A, but not equal A. So you write it limit x approaching A of fx is equal to infinity, or fx approaches infinity as x approaches A. Notice infinity means positive infinity here, right? So the symbol infinity is not a number, but the expression limit x approaching A fx equals infinity is read in these ways. Limit of fx as x approaches in A is infinity, or fx becomes infinite as x approaches A, or fx increases without bound as x approaches A. What does this mean? Here is a picture. So here is value A. At A, notice f is not defined. So f is undefined at A. But to the left of A, my function is growing. Okay, indefinitely. That's what it means to grow without bound or approaching infinity. Likewise on the right, as my graph approaches infinity as x approaches A. Okay, as we get nearer and nearer A, the graph goes to positive infinity. Both sides, that's why it is called infinite limit. Here is negative infinite limit. So when at A, my function is not defined. It could be defined, it could be 5 for all you know, but it doesn't matter. In this picture, it is not defined. To the left of A, this branch is going to negative infinity. To the right of A, this branch is going to negative infinity. So you say limit x approaching A of fx is negative infinity. All right. So definition, what does it mean in words? Let f be a function defined on both sides of A except possibly at A itself. Then limit x approaching A fx is negative infinity. This means that the values of fx can be made arbitrarily large negative by taking x sufficiently close to A but not equal to A. The symbol limit x approaching A fx is negative infinity is read limit of fx as x approaches A is negative infinity. All right. So our fx decreases without bound, decreases. So it's keep going on, go down. As an example, we have limit x approaching infinity of negative 1 over x squared. You might want to draw this picture for yourself. It goes to negative infinity. Okay. Looks like they don't have a picture for the same. So let me graph this for you. Whoops, where did I go? Function plot. So you're looking at negative 1 over x to the power 2. You see how this looks like. If you want, zoom in. As x approaches 0 from the left, you go to negative infinity. As x approaches 0 from the right, you go to negative infinity. So that's the picture. Okay, limit is negative, infinity. All right. Next, so here are different possibilities. For a number A, let's get close to see. Left-hand limit could be positive infinity. Left-hand limit could be negative infinity. Right-hand limit could be positive infinity. Right-hand limit could be negative infinity. Okay. So X approaches A minus means you are looking at values that are less than A. X approaching A from the right means we are only looking at values greater than A. That's what makes it right. So here are the possibilities, right? So left hand limit is positive infinity. So here is A, left branch goes to positive infinity. Left hand limit is negative infinity. Left branch has gone to negative infinity. Right hand limit has gone to positive infinity, and right hand limit has gone to negative infinity. Okay. The vertical line at A, x equals A, is called vertical asymptote. When do you have a vertical asymptote? This is the definition, it's important. You get a vertical asymptote if at least one of these has to happen. Limit is infinity or limit is negative infinity. Left hand limit is infinity or left hand limit is negative infinity. Right hand limit is infinity or right hand limit is negative infinity. So at least one of these have to happen. That's what it means to have a vertical asymptote. Here is an example of tan x. Tan x is sine over cosine. You know cosine is 0 when x is pi over 2. So you're taking limits, left hand limit and right hand limit, okay, of tan. You get one of the infinities. All right, so this is important. The infinities are different. You can see from the picture. That's 0 there. Okay, so here is pi over 2. Left hand limit towards pi over 2 of tan is positive infinity. Right hand limit is negative infinity. So notice, left and right hand limits don't have to be the same infinity. They can be different infinities. Okay. So we complete our lessons lecture slide for section 1.5. Next videos will start with problems on the web work from section 1.5. So until then, bye.